Let's start into Newton's laws problems now with two objects. So two objects connected by a string or by a rope here. I put back up the rules for free body diagrams for you because really I've been saying this the entire time. Free body diagrams is where you live and die with Newton's second law. If you get it right, you're going to be fine. Let me point out rule number one, and this is really why I have it up. Draw object or objects as point masses independent of all other objects. So you're going to draw each object independent of others, one free body diagram per object. So if you have two objects, you're going to need two separate free body diagrams. Now there's going to be tension in both of these. If I were to draw a free body diagram for them, right, there's going to be tension in both of them, and that tension is going to be the same. It's what's going to connect them. So let me draw a quick free body diagram for you. Object number one over here would look something like this, right? I'd have tension going this way. I might have friction going back to the left, normal force going up, and the force of gravity going down. Object number two is vertical over here, right? So I would have tension going up and just force of gravity going down. And if I had to guess about this, I'm going to guess that the tension here is greater than the force of friction, specifically because I'm guessing that gravity here is pulling box number two down harder than the force of friction on box number one can resist. But you'll see how that works out mathematically in the next problem. All right, so a trebuchet is a medieval siege device used to attack castles or used in castles to defend when someone's attacking that uses a large counterweight that is dropped, accelerated by gravity, to accelerate a smaller weight that then will be launched out at people. Now, most of them use centripetal force. The advantage of that is it's smaller in size. It doesn't take up as much room. But one way would be just to have a surface, right, and to cause a large mass to accelerate to the right and then over the castle wall towards people by dropping a large weight that is attached to it, probably some sort of sling holding it in place so then it can launch off. So that's the basics of what we have going on here. I have two objects, object one with a mass of 20 kilograms and object two with a large mass that we're allowing to fall. And my question that I want us to answer here is, what is the acceleration of object one to the right? So how fast is it accelerating here? Then it's going to launch off at the people. Now there are two objects, so I have to draw two free body diagrams. So object one, I have normal force going up, Fn, because it's on a surface, right? I have force of gravity going down. I have tension pulling it to the right. That's what's pulling it, right? The rope is what's pulling it to the right. And I have friction coming back to the left. Notice I drew friction a little bit smaller than tension because I'm assuming that we are going to accelerate to the right here, that friction isn't going to be able to balance out this massive counterweight. Object number two, I only have two forces. I have tension going up and gravity going down. Now let's go ahead and let's address an issue whenever you have two objects. Whenever picking positive and negative, you can't just pick whatever you would like. You have to pick system positive and system negative. So let me show you what that means. I'm going to pick positive and negative for object number one. I'm going to call to the right positive, to the left negative, and up positive, and down negative. Now, that right there has ramifications for object number two because you just can't pick whatever you want. Notice that if I call to the right positive for object number one, whenever number one moves to the right, object number two is going to move down. Does that make sense? So to the right positive for number one, that must mean down is positive for number two, system positive, right? Going down to the whenever it moves to the right, positive, so down must be positive for number two. Likewise, if object one moved to the left, going this way, right, object number two is going to go up. Now I call it to the left negative for number one, so object number two up must be negative because that's the direction it would go, right? So think of tracing the entire rope here. If you call to the right positive for number one, trace the rope positive, 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 down now is positive. If I'm calling to the left negative, right? So everything that goes left is negative whenever object one goes left, right? Negative, so tracing the rope negative, 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 up must be negative if left is negative. All right, so let's write some of the forces for all of our objects. So for object number 1, I have an x and a y axis because I have forces going in both axes, right? Object number 2, though, I only have one axis I have to deal with, the y. So now we just simply need to look at our free body diagrams and read off what I find. So in the x-axis of number 1, I have tension. Let me make that the correct color here. Tension minus the force of gravity, the force of friction, equals ma. And in the y-axis, I have normal force minus the force of gravity equals ma, just reading off the free body diagram. In object number 2, I have, now be careful here, down is positive because the system positive, system negative. I have Fg minus T equals ma. All right, now this is the point that I want everyone to be able to get to at least, right? And then we'll go beyond that solving. But you should be able to get here. It might take you a little bit, but you can do it. Even if you're not sure how to solve for the acceleration here in the x-axis of object 1 going to the right, solve for this A, you should be able to get here drawing a free body diagram of the two objects. Right, now the system positive, system negative might confuse you a little bit. We'll work that out, don't worry. Okay, but then you write sum of the forces for the x and the y of object number 1, the y of object number 2. So every axis that has a force in it, give us sum of the forces, and then just read off what's in your free body diagram. Next step here, anytime you're working a complex problem, or really any physics problem, I would advise you to go right for the goal. Start solving for what you want to get. A in the x-axis. I want to know what's the acceleration of object number 1 going to the right. Okay, so I'm just going to start working x-axis of number 1. Tension, I don't know that. Force of friction always breaks into mu times normal force equals ma. So now let's plug in some numbers. All right, so I'm able to plug in the coefficient of friction. I was told that, 0.2, and we'll give ourselves an extra sig fig here. We'll make it 0.20. So I was able to plug that in, and the mass, but I have a couple of problems. To solve for A, I need to know what normal force is and the tension in the rope. Now you've dealt with friction enough that you know where to go to get the normal force, the y-axis of that object, right? If I come over here, I can get normal force. So Fn minus force of gravity always breaks into mg equals ma. All right, plug in some numbers. All right, so now that I have solved for normal force, I can plug that in over here, right? So let's rewrite that. I'm going to need a little bit more space, so I'll come down here. T minus 0.2 times 196.2 equals 20A. Well, that's great. So now I have down normal force, but I still have a problem. To solve for A, I need to know what the tension is. And there's really only one other spot left to go get that, right? It's the y-axis of object number 2. Notice that the same rope attached to object number 1 is what's attached to object number 2. So the tension throughout it is going to be constant. So the same tension that's trying to hold object number 2 up is what's pulling object number 1 to the left. So let's start working in object number 2. Force of gravity always turns out to be m times g minus t equals ma. So plug in some numbers. Make sure also you use the mass of object number 2. Notice I'm in object number 2 now. So the mass of object number 2 is 75 kilograms. You might say to yourself, uh-oh, I'm looking for this tension, so I can substitute it in, right? But I have a problem. I don't know the acceleration of object number 2. It's not 0, it's falling, right? It's some acceleration. Well, this is okay, because since they're connected with a rope, the two objects, not only is the tension the same here between them, but their accelerations are the same also. The same acceleration object 1 has to the right, object 2 will have down. So let's solve for t, and it will have a variable in it, and substitute that in. This is a standard system of equations. All right, so I solved this equation now for t. This is system of equations, right? I solved this all the way down for the tension. That's going to allow me to substitute it in up here for the tension in the other one. Thus, I'll get just one equation with just one variable, A. So now I have taken the equation for t and I've substituted in for t here inside the brackets, right? And then my force of friction, the mu times normal force minus that, is still here, and the 20A is still here. And notice now I have an equation with just one variable, A. So now I need to collect like terms and continue to work the algebra. All right, so I just multiplied 0.2 times 196.2 and came out with 39.24. Combining like terms, the 735.75 and the 39 gives me 696.51 minus 75a equals 20a, and I'm going to add that 75a now to the other side, so 696.51 equals 95a, and now we divide both sides by 95 and get our final answer, an acceleration of 7.3 meters per second squared. So that's a decent acceleration trying to get this object to launch off. Now, hear me very clearly in this. There's a lot of algebra. Don't freak out about the algebra. Practice will make you perfect at this, so don't worry, we'll get there. I need you to understand the physics, specifically the free body diagrams, and then knowing what forces to write. Doing the algebra from there is something we'll practice, and you'll be fine at it. You might want to go back through this video, pause it a couple of times, and just look at the algebra as we go to understand what I'm doing step by step by step, and make sure you come with questions to class tomorrow. An idea might be with your questions to actually pause the video and write down the time that something occurred, the time on the video that is, that something occurred that you're not sure about that you want to ask me, so that we can pull up the video in class, actually scroll to that time and look at what was happening.